Coming to lab session on activity one, I'm using Tinkercad here. Just I log in with my personal login. So once you log in this, you need to go to new design here. Under new design, just click on circuit. Once you are clicking on the circuit, it will open a default project name. But if you want, you can change as activity one. Then coming to this Tinkercad, here first it is providing a workspace where you can drag and drop all components and make the connection. And right side, if you observe here, there are so many components are available for your applications. And these are basic components. If you want to choose all components, you can also select the all components option. So more number of components are listed in all component list. Based on our requirement, we need to pick up the components and place within the workspace. So as per our problem statement, once again, we can recall our problem statement. We need to design a smart system which can control the LED based on the switch position. When switch is pressed, push button switch is pressed, LED should be turned on. Otherwise, it should be turned off. So for this, we need to require several components. First, we need to drag and drop all these components. First and foremost component is Arduino Uno. Arduino Uno. So first, place Arduino Uno in the workspace. Then bring one breadboard. In order to make the connections, bring one breadboard. I'm going with basic components now, and just use a breadboard for making the component connection. So I'm going with this breadboard, and first we need to know how to connect the components in breadboard. So if you observe here, there are top and bottom, there is a plus sign and minus sign. Similarly, here bottom also plus sign, minus sign is there. Here these 30 dots are connected horizontally, and in plus sign also horizontally 30 dots are connected. And similarly, in the middle dots A, B, C, D, E are connected, and F, G, H, I, J are connected. That means if you want to connect any two terminals or any two components, just you need to put one of the lead in this, one component lead in this one, another component lead in this one. So this will make the connection between two components. So first, basically, in order to make the connection, we require 5 volts multiple times. So that's why normally you can provide one VCC on breadboard. So that means here the 29 lines starts now become 5 volt on the breadboard. And similarly, I am connecting one more wire with negative terminal. So this negative terminal now behave as a ground, means 0 volts. And then as per our requirement, consider LED. So bring one LED into this breadboard, and if you observe this cross wire on the LED will represent the anode, and this one represent the cathode. As per our schematic diagram, first we need to connect anode to resistor. So pick a resistor from component list and make the connection like this. and make sure that the size of the resistor should be 220 ohms. Already we calculated in our calculations. And then the another end of the LED, that means cathode. The cathode should be connected to ground, and the anode is connected to third pin of the LED as per our circuit diagram. And here you can change if you want a color. I'm using a blue color wire for connecting the resistor, and I'm connected here this path. Third pin is connected to a resistor. The resistor another end is connected to anode. The cathode is connected to ground. So that means the LED connections are over. We need to use the push button switch. Here already available here. It's it is available here. Just we need to make the connection now. To make the connections, normally you need to place switch in the middle like this only. If you are placing like this, there is a short of this 1A, 1B and 1A. So in order to overcome this, always you need to place like this and use diagonal element, diagonal terminals. So if you want to use this one, so next alternate one, 2B you need to use 1A and 2B or 2A, 1B. So these combinations you can use now. This is the switch one terminal. One of the switch terminal should be connected to directly connected to ground VCC 5 volts, and so I'm using this one now. From here you need to connect one end. I connected to VCC here. So let us change the color, and another end should be connected to ground using a resistor. So for this, I am picking one more resistor here. The resistor size is here. I'm connected a resistor. So let us consider this one with some other color green. And from this line, I am connecting this wire to input terminal. Switch is as per our schematic diagram, switch is connected to 8th pin. From this, I connected a resistor. The resistor another end should be connected to ground. So here it is connected to ground. Then after making the connections, and one more thing here, we need to change this one size is also 220 ohms. The resistor size is also 220 ohms. Once we make the connections, then we can go with the code. And under code, you can use either blocks, text, and text. Normally, as a programmer, we need to go with text only. So that's why I use the text option. In this, some default code is available for blinking of LED. So as per our requirement, I need to program our application. So as per our code, I am writing now in mode 3 comma output, mode 3 comma output, and in mode 8 comma input. So from these two commands, initialization is completed. Third pin is connected to LED, so that means it is programmed as output, and whereas 8th pin is connected to switch, that is programmed as input. In the loop function, we need to write actual application. So here we need to read the data. Int x is equal to digital read of 8 comma 8 only. So that means whatever the value is available on the 8th pin is stored in the x variable. So then we need to use a condition. If x double is equal to, if x double is equal to 1, means switch is pressed. Once switch is pressed, what we need to do? We need to send logic 1 onto, to send logic 1 onto third pin, we need to write digital write command, digital write 3 comma R1, logic 1. So then if the condition is not met, that means if switch is open, then what we need to do? Else condition, else means x is equal to 0. If this condition is met, so we need to write logic 0 onto third pin. So simply you need to change 3 comma 0. Then your program is completed. Once your program is completed, then you need to start simulation. If you start the simulation, you can observe here. Previously, it is not connected to plugged into USB cable. Now it is plugged in. Once it is plugged in, this you can observe here. LED is not glowing, but when it will glow when you will press this switch. By clicking my mouse on the push button, so the LED is continuously on. If I remove this one, it is off. So that means I implemented controlling of LED using a push button switch. You can see now. So by clicking the mouse, it is turned on. If you remove this one, that means I press the switch, LED is on. If I remove the switch, LED is off. Thank you for watching.